Lesson 7.3. We're going to start this video with looking at Lesson 7's learning target. It says, I can decide if a relationship represented by a table could be proportional and when it is definitely not proportional. So the key is proportional and not proportional. We're going to be looking at tables and deciding which ones are proportional and which ones are not. 7.3 Running laps. Han and Claire were running laps around the track. The coach recorded their times at the end of laps 2, 4, 6, and 8. We have Han's run here and Claire's run below. And we want to answer these two questions. Number 1, is Han running at a constant pace? Or is Claire, and how do you know? And then 2, write an equation for the relationship between distance and time for anyone who is running at a constant pace. So we're going to complete these tables. We notice it says distance in laps, time in minutes, and minutes per lap. So when I see the minutes per lap, I'm going to think of that as minutes per lap, as if a fraction, a ratio of two things. So we have our time in minutes over the distance in laps. So we're going to do 4 divided by 2. 4 divided by 2 is 2 minutes, so it's 2 minutes per lap. And then we have the minutes are 9 and 4 laps, so it's 9 over 4. Now 9 divided by 4 is 2 and 1/4, or 2.25. And then we have 15 over 6. 15 divided by 6, that's 2.5 times, 2.5. And then 23 over 8. Now 23 over 8, a little bit more difficult, so I'm going to use a calculator. 23 divided by 8, that's going to be 2.875. So again, that's 23 over 8, and that is 2.875. So as we can see, the minutes per lap here are changing. We can kind of think of this as a proportional relationship if we put x over the distance here and y over the time. And what we've just done here is y over x. That's my k. I'm checking to see, is there a constant minutes per lap? And for Han here, we can see as time goes on, as he runs more lap, it takes longer to run those laps. It starts out at 2 minutes per lap and ends at 2.875. So he must be getting tired out. It takes him a little bit longer to do that run. Let's check Claire's. Her 2, 4, 6, and 8, we have 5 minutes, so it's 5 over 2. 5 divided by 2 is 2.5 minutes per lap. The next one, we're going to do the minutes per lap over the distance, so it's 10 over 4. That's equivalent to 2.5 minutes per lap. And then 15 over 6. Again, that's 2.5 minutes per lap. And our last one, 20 over 8. And that is 2.5 minutes per lap. So on her, if we look at the minutes per lap, they never change. They add a constant 2.5 minutes per lap. So again, we can think of these as x and y and our k value, because we did y over x to get k. And we can see that that's a constant rate of 2.5 minutes per lap. So is Han running on a constant pace? For Han, it's no. And for Claire, it's yes. Because she's doing a constant. That constant is 2.5 minutes per lap. Question 2. Write an equation for a relationship between distance and time for anyone who is running at a constant pace. Anyone at a constant pace. So again, let's look here. We have Han and Claire. Claire was running at a constant pace of 2.5 minutes per lap. If we think of this as a proportional relationship, y is equal to kx, where my minutes per lap is my k. For Claire, we could write y, the time, is equal to 2.5 times the x, which is distance. So instead of using x and y here, I'm going to use t equals 2.5 and d. So the distance times 2.5 is equal to the time. That is for Claire. All right. So if we write anything similar here, we can have the time is equal to the minutes per lap times d. Now, we usually just would put a number for our constant proportionality, the minutes per lap, but since it's for anybody, we'd have to have that minutes per lap being calculated. That would be our constant proportionality, but the T would be the Y, minutes per lap would be your rate, and the distance D would be last. So again, this is about comparing two tables and deciding which ones have a constant proportionality. As we can see, it was Claire because she ran at a constant rate.